Well, children, again I am with you from Saturday Physics. Today my mode of discussion will be on dipole potential electric field by polar coordinate method. Suppose let us consider a dipole. Let us consider a dipole minus q plus q. Okay. Now P is a point whose polar coordinate from the middle point O is r theta. Length of the dipole is 2L. Dipole moment q into 2L, that is vector p. Clear? Now polar coordinate of p, polar coordinate equal to r theta. Now we try to calculate potential for dipole at the point P. Now A and B, this is the dipole. Now AP equal to R1 and BP equal to R2. This is AP R1 and BP R2. Clear? Now if you extend the PO and draw perpendicular, that is AE, and from B you draw perpendicular on OP, that is PF, that means OF. Now we have, this is theta, so this angle is theta. So from triangle OE we have OE by AO, that is L, equal to cos theta, that means OA equal to L cos theta. Clear? Similarly OF equal to L cos theta. So first again I am telling, if P is a dipole, now P is the point whose polar coordinate is r theta. Now length of the dipole is 2L. You draw perpendicular from A on extended PO at the point E. Now from this triangle OE by AO equal to, you are getting OE equal to L cos theta. Similarly OF for triangle you write down BFO for BFO. So we have R1 equal to, now R1 equal to L plus, this is L and this is OE, that is equal to this R1 equal to, this is R1 equal to, you are writing R plus L cos theta. How are you getting? That is, since R1 equal to OP plus OE from the figure, and R2 equal to, that is R OP minus L cos theta. R2 equal to L R minus L cos theta. So distance from the charge minus q and plus q we have got. So potential V equal to potential for positive charge plus potential for negative charge. Clear? So we have, you write down, we have charge positive 4 pi epsilon naught R minus L cos theta minus q 4 pi epsilon naught R plus L cos theta. Clear? So we have, you take q by 4 pi epsilon naught common, you are getting R plus L cos theta minus r plus L cos theta, and denominator is coming r square minus L square cos square theta. So we have potential V for r theta, we are getting q by 4 pi epsilon naught, that is equal into 2L cos theta. Already q and 2L equal to p cos theta, so we are getting 4 pi epsilon naught r square, since r square greater than L square cos square theta. So along now is we are getting potential for this. Potential for r theta, you are getting this p cos theta 4 by epsilon r square. Now along the axis theta equal to 0, or the v axis equal to p by 4 pi epsilon naught r square. Similarly, if theta is 90 degree perpendicular bisector, so if theta 90 degree, then v equal to 0. That means along the perpendicular bisector, if theta 90 degree along the perpendicular bisector, we are getting potential is 0, but along the axis p 4 by epsilon r square. This is a general expression for polar coordinate. It is better you derive the whole potential for polar coordinate. Why it will benefit you? It will benefit in the sense that separately you have to not consider the axial point and perpendicular bisector point. Only change the situation. If theta equal to 0, you are getting the potential along the axial line. Theta equal to 0, you are getting dipole moment along axis. That is, you are getting, already you have got p by 4 pi epsilon naught r square. But if theta equal to 90 degree along perpendicular bisector, you are getting v equal to 0. That every point on perpendicular bisector v is 0, that is 0, that is 0. So all are 0 along perpendicular bisector line. So now we have derived the relationship of dipole for potential when point of interest P having polar coordinate r theta. Okay. Now we are going to calculate electric field for dipole. For in general case, let us calculate electric field for dipole. Let us calculate electric field for dipole. Electric field for dipole. Already potential V equal to P by 4 pi epsilon naught r square cos theta. Already I have got. You know electric field E equal to along the axis, that is ER, or along the perpendicular, that is I and E theta along the J. So ER equal to minus dV by dr. You calculate dV by dr. Clear? So this is the dipole, that is minus q and that is plus q. That is the point P along the axis ER, along perpendicular axis E theta. If you complete the parallelogram, you are getting alpha. Now E theta, you are getting 1 by r dv by d theta. So v is given. First you take the derivative with respect to radius vector, that is the r, and take the derivative with respect to theta. So er equal to, are getting minus d by dr p cos theta 4 pi epsilon naught r square. So this is constant, it will come out. So minus 2 into 1 by r 4 pi epsilon naught r cube. So you are getting, since er equal to minus dv by dr, so er you are getting, that is minus, and another one minus is coming. So 2 minus, after taking derivative r to the power minus 2, this minus coming, and minus dv by dr, another minus coming. So it is coming 2p cos theta 4 pi epsilon naught r cube, that is the er, equation number 1. Clear? Again I am telling, er equal to minus dv by dr. First you calculate dv by dr, you are getting this value, then minus plus, so 2p cos theta 4 pi epsilon r cube. Always remember, electric intensity inversely proportional to r cube. Similarly, d theta is coming minus 1 by r dv by d theta. Clear? So you are getting minus 1 by r d by d theta p cos theta 4 pi epsilon naught r cube. This is constant, r square. This is constant, you take out. So it will be plus cos theta will be sin theta. So it will be 1 by r cube 4 pi epsilon naught p sin theta. Or you can write freshly p sin theta by 4 pi epsilon naught r cube. How it is coming? D theta 1 by r minus 1 by r d by d theta p cos theta is 1 minus sin theta minus 1 is a plus, cos theta derivative will be sin theta minus sin theta. So minus is coming out, minus 1 is a plus. So 1 by r cube 4 pi epsilon naught p sin theta 4 pi epsilon r cube. So according to vector of electric field equal to root over E r square plus E theta square. Clear? So you write down, put the value square, then common term 2p, it is coming p 4 pi epsilon naught. So it will be 2 4 cos square theta plus sin square theta, and outside it is coming p 4 pi epsilon naught r cube, or you can write down p by 4 pi epsilon naught r cube root over, you break 1 minus cos square theta, so it will be 3 cos square theta plus 1 general value. And if this resultant field makes angle alpha, if E makes alpha with ER, then tan alpha equal to E theta by ER. Already E theta you have calculated by ER, then you are getting half tan theta. So angle tan inverse half tan theta. Now case 1, if E along the axis, then theta equal to 0 degree, then E axis will be, if it is 0, then cos 0 1, that is 4, so it will be 2p 4 pi epsilon naught r cube. Clear? E perpendicular bisector theta equal to 90 degree, E equal to theta equal to 90 degree, then it will be E perpendicular bisector will be P by 4 pi epsilon naught r cube. So it is clear, I think. So first I have calculated potential for dipole. After that, from the expression of potential, you know electric field is conservative force field. So we have used this formula, E equal to minus delta V, or you can write dV by dr. This concept I used here. This concept I used here for polar coordinate. This way I have calculated general value of the electric field along the P at the point P for polar coordinate r theta. Now taking case 1 we have, and case 2. Case 1 is the theta equal to 0, that is along the axis, and case 2, that is along the perpendicular bisector, that is P by 4 pi epsilon r cube. Clear? So now this is the lesson I have taught you. After next class we are giving trace on capacitor chapter according to NCERT syllabus. Thank you all. If possible, to encourage me, all children are requested to subscribe my channel so that I can be motivated to do better for you. I hope you will do so. Thank you all children, my dearest children. I hope this lecture will benefit you in the long run.